Number 7 involves some more trig. All right, we're interested in the value of y when x is equal to 0. All right, so in essence we want y of 0. Y of 0 will be equal to the initial condition that we have here, which is y of pi over 2, plus the integral from the point we know to the point we're trying to find of our derivative, sine x cosine squared x dx. Okay, this is what we need to calculate. So y of pi over 2, right, the y is equal to 0 when x is equal to pi over 2. So y of 0 is just going to be 0 plus this integral right here. Now this integral, again, should trigger that we are backwards. All right, our bounds, the 0 should be down at the bottom. So we're going to change that to a minus the integral from 0 to pi over 2. And now we have to deal with this graph right here, or this integral right here. This is going to involve some u substitution, it looks like. Okay, so let's put it down one more time, and then let's figure out our u substitution, because we have a product here. So the inner function is actually going to be cosine of x, because we have the cosine of x being squared. Right? The derivative of cosine is the opposite of the sine of x, dx. Well, we have the dx and we have the sine of x, but we don't have the opposite sign. So we need that opposite sign, which means we need another negative sign out front. This negative sign is going to cancel with that negative sign to bring it back to being positive. All right, and basically that's putting it right there. And now we can do our u substitution. We don't need to write the 0 plus anymore, so we just have the integral from 0. Oh, no, I'm not write the bounds yet. Cosine is being replaced by u, so it's u squared. The negative sine x and the dx, they're being replaced by du. And then our bounds, well, we have to plug 0 and pi over 2 into cosine. So we have the cosine of 0, that would be 1. And then we have the cosine of pi over 2, that would be 0. All right, so if we look at this, again, our bounds are backwards, so we need to swap them. And so we have the opposite of the integral from 0 to 1 of u squared du. Well, u's antiderivative, that's going to be u cubed over 3. That's being evaluated from 0 to 1, and the negative sign is still there. We plug the 1 in first, so we have negative 1 cubed over 3 minus 0 cubed. Well, technically it's the opposite of 0, but you can't do that, over 3. That's all 0, so that all wipes out, and we have negative 1/3, which is our answer. And then last, we have number 8. The graph of f prime is shown. If f of 0 is 20, which of the following could be the value of f of 5? Well, let's do another one of these equations. F of 5 is equal to f of 0 plus the integral from 0 to 5 of f prime of x dx. So the integral from 0 to 5 of f prime of x dx, that's going to be, well, here's 5 right here. That's going to be all this region right here. Okay. And we're going to add it to the 20. Now, obviously, trying to find this entire shaded region is impossible to do because we don't have a formula for it. Okay. But let's try and simplify things. Notice how the graph is always above that line right there. Well, what's the area of this blue rectangle? Yeah, it's 10. We have a base of 5, and we have a height of 2. So the area of that blue rectangle is 10. So this value right here is at least 10. Okay. When we add 10 to the 20, we get 30. So we need an answer that's at least 30. So 15, 20, and 25 are out. The answer is either going to be 35 or 40. Let me draw another line. Let's say I draw this line right here. Now, what's the area of this region I've just shaded in pencil? Yeah, it's 20 exactly, because now our height is 4. 4 times 5 is 20. Now we are definitely, we don't have all this area right there. We're missing that. So 20 is too big. If we were to add 20 to 20, we would get 40. But we know that that's too big because we are missing this area in this region. So 40, that's too much. So the only answer that works is 35.